Hello everyone. In this session, we are going to discuss about Power MOSFET. So normally MOSFET stands for metal oxide semiconductor field effect transistor. So it is a voltage control device, and the BJT which we have previously discussed, it's a current control device. So normally Power MOSFETs are designed to handle high current and voltage with a very fast switching speed. So we have some types of MOSFETs. So we have enhancement type MOSFET and depletion type MOSFET. The enhancement type MOSFET, in that we have N channel enhancement MOSFET and P channel enhancement type MOSFET. Depletion type, we have N channel and P channel. So the difference here is in enhancement, we don't have the layer in in the device. The layer is created when the external biasing, when a biasing is done. But in depletion layer, the layer is already present. And the N type and P type by symbol, how we'll represent here is in N channel, the arrow mark will be towards, and in P channel, it will be away from the source. In source, it will be away. And next comes the structure. So this is your structure of MOSFET. So normal, it has three terminals: gate, source, drain. So the gate is insulated by a thin oxide layer, that is no current, no gate current flows, and to the other junctions. That is, it's a thin insulated layer. A source is where uh, the current carriers, charge carriers enters, and drain is where the current carrier, charge carriers exist. So the source is your input and drain is your output. So here the channel forms between source and drain when output is applied at the gate. So here we have some modes of op operation. Before going to the modes, we'll just see how it's working. So normally we don't have a channel. The channel will be here, okay? We don't have the channel externally. For example, in order to make the N channel here, we have to have a, normally in N type, your majority charge carriers is electrons, okay? So in order to have the electrons, what we have to do here is, we have a P substrate below that, right? So there will be some minority charge carriers. The minority charge carriers in P type is electrons. So what happens when we have to supply the voltage such that the electrons in the P layer will be attracted towards gate. That is the right, this is your P type layer. When I'm giving supply, that is, I'm giving supply positive to the gate. So what happens? Opposite attracts, right? So what happens here? Your negative charge carriers, that is your electrons are negative, right? So electrons will be going towards the positive charge, I mean toward the positive supply which we have given in the gate. So this is how the N channel layer, type layer is formed. In order to have a P type layer, the procedure will be opposite, okay? So this is how the channel is formed in enhancement layer. So for example, we have two modes. One is off state. In off state, the gate to source, that is VGS, will be less than the threshold voltage. So what happens here is no channel formation will be done there. So no current will be flowing. So it will be acting as a switch. So in on state, what happens here is when the gate source voltage is greater than your threshold, there will be a layer formed between the source and drain. So there will be current flowing between drain to source, and it acts as a close switch. So that's all. Here we have, I'll repeat, when a positive charge is applied to the gate, it attracts electrons. So these electrons form a conductive path between source and drain. So this is how it works. We have some advantages of MOSFET. So normally MOSFET are high switching speed. That is, we are preferring MOSFET when compared to BJT. And it has very low gate power requirements, and it has high input impedance, and the compact, it is in compacted size, and efficiency is also very good. Where we can use this MOSFET is DC to DC converters, SMPS, motor control circuits, and inverters for renewable sources like that. So here we have some VI characteristics, that is voltage current characteristics. So here VI characteristics plotted between your drain source voltage and your drain current because your output is drain. So what happens here? We have cutoff region, active region, and this is your ohmic region. So what we'll be doing here is we'll be keeping our gate source as constant, and we'll be taking the values in order to see the characteristics between VDS and ID. So this is how, and this is the switching characteristics of MOSFET. So here, this is your turn on time. Turn on time, we have delay time as well as rise time here. In turn off, we have delay fall time and fall time. So this is how the switching, this is the switching characteristics of MOSFET. And that's all with the MOSFET structure characteristics and working principle. So thank you.